This is the physical science lesson video for section 3.2, and as always, if you want all my videos in one spot, just subscribe to my channel. So we're going to talk about the gas laws. So pressure is a result of the force distributed over an area. So it's force over area. If you're actually calculating it, P equals F over A. The SI unit for pressure is the Pascal, which is abbreviated as PA. So what causes pressure? Well, it's collisions between particles of a gas and the walls of a container. That's what causes the pressure. So if particles aren't colliding, you can't have any pressure. The more frequent the collisions, the greater the pressure. So when we talk about does pressure increase or decrease, what I want you to think of is, are there more collisions? Because if so, pressure increases, or are there less collisions? And if so, pressure decreases. The speed of the particles and their mass also affects the pressure. So like I said, whenever you're thinking about pressure, you just need to think, how many collisions are happening? Are we increasing collisions, which increases pressure, or decreasing, which decreases? So what factors affect gas pressure? Well, the factors that affect gas pressure of an enclosed gas are its temperature, its volume, and its number of particles. Those will determine how many collisions are occurring. So temperature. As the temperature rises, the average kinetic energy of the particles in the air increases. Raising the temperature of a gas will increase its pressure if the volume of the gas and number of particles are constant. So if we have an enclosed gas here, and we're at a lower temperature, and we heat it up, the particles will move faster. If the particles move faster, are we going to have more or less collisions? More collisions, so that means more pressure. Think about the opposite example. If I have a hot gas and I cool it down, if I cool it down, the particles slow down, and then they collide less often, causing less pressure. Again, if you'll think about it in terms of collisions, it's really easy, and you don't really have to memorize that much stuff. Volume. Reducing the volume of a gas increases its pressure if temperature of the gas and number of particles is constant. So this picture is actually terrible quality, but it's a good picture. So say this is our gas originally. If we decrease the volume, we have the same amount of particles, but now they're all close together. So if they're close together, they're going to collide more often. Think about if you're in a room with 3 people versus in a room with 20 people. Where are you going to bump into people more often? In the room with 20. Okay, so we have all these particles packed in this tiny space. Well, actually, that was a terrible example because that was based on number of people. So say you have 20 people in a big classroom versus 20 people packed in a closet. The people in the closet are going to bump into each other more often. So the closer the particles are, the more collisions. And then look over here. Like if we decrease volume even more, those particles are almost touching at this point. And so in that case, we would have even higher pressure because even more collisions would be occurring. Number of particles. Increasing the number of particles will increase the pressure of a gas if temperature and volume are constant. So this is my example of the 3 people versus 20 people in a room, but I already blew that, so let me just use the normal example. Okay, so here we have some of these red gas particles, but if we now add the blue ones, you're going to have more collisions with more particles of gas. And so in that case, this would have the higher pressure of the two. Charles' law states that the volume of a gas is directly proportional to its temperature in Kelvin if the pressure and the number of particles of the gas are constant. All right, so directly proportional, for those of you who don't know, that means they do the same thing. So if volume increases, temperature increases. If volume decreases, temperature decreases, like that. So think about this. You know how this works. If we have a gas in a container and we heat it, what do those particles want to do? Well, when they heat, they're going to move faster and they want to expand. So if we increase temperature, volume also increases. And then on the opposite hand, if we then cool it back down, volume will decrease. So directly proportional means they do the same thing. Boyle's law, on the other hand, states that the volume of a gas is inversely proportional to its pressure if the temperature and number of particles are constant. So inversely proportional means the opposite. So if one goes up, the other goes down. And so Boyle studied volume and pressure. And so again, here is our container. If we increase pressure, so if I push down, if there's a gas in here, and I push down on this, if I push down and decrease volume, well, now the particles are much closer together. They're going to collide more often, so pressure increases. So I decrease volume, but pressure now increases because of more collisions, and that's Boyle's law. So, section assessment. How is the gas pressure produced in a closed container of a gas? Well, it's the collisions of the particles with each other and the walls of the container. The collisions of particles. Number 2, what 3 factors affect gas pressure? Well, there's temperature, there's volume, and there's number of particles. Temperature, volume, and number of particles. Number 3, how does increasing the temperature affect the pressure of a contained gas? So think about this. If we increase temperature, particles move faster, they collide more, so pressure increases also. Okay, so pressure would increase for number 3. Number 4, what happens to the pressure of a gas if its volume is reduced? So if I have a gas in this container and I force the volume to reduce, the particles are going to be closer, so they're going to collide more, so pressure also increases. Okay, so if we reduce the volume, pressure will also increase. Number 5, how does increasing the number of particles in a contained gas affect its pressure? Well, if I put more particles in there, there's going to be more collisions, so again, an increase in pressure. Wow, hopefully you could have just guessed increase, 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 because that's what I just did for those. Number 6, what happens to the pressure in a tire if air is slowly leaking out of the tire? Well, obviously increase, because that's the answer to all the other ones. I'm just kidding. It's not the answer this time. Okay, so here air is leaking out of the tire, so we have less particles in the tire. Well, less particles mean less collisions, and so there would be lower pressure in the tire. Lower pressure. So number 7, what do Boyle's law and Charles' law have in common? How are they different? Well, Boyle studied volume and pressure. Charles studied volume and temperature. So what do they have in common? They both deal with volume, but how are they different? Well, Boyle did pressure and Charles did temperature. And then number 8, explain why an aerosol can should never be thrown into a fire. Well, an aerosol can is already under high pressure. That's why when you squeeze it, it sprays out because it's pressurized. So if it's already under high pressure and then you heat it, you're going to increase the pressure, which can cause it to explode. And so that's why you shouldn't throw it in the fire, because that increase in temperature will cause an increase in pressure. All right, so hopefully you understand a little bit more about pressure and the factors that cause pressure and change pressure in Charles and Boyle's law.